is Giancarlo Gomez, and we'll be talking about WebSockets 101 today. So this is an introduction to WebSockets. Before I start, I was asked to remind everybody to download the CF Summit app and then register to the classes you're going to. And once you do that, once you add it to your schedule, you'll see this. You'll see the oh my God, what's the word I'm looking for? The surveys. And if you enter the surveys, you'll be automatically added for a raffle for an Amazon gift card, and that's good for every session available. Not every session available, but for every time slot. So like for this time slot, you're going against everybody in this particular time slot in all the sessions. So the next one and so on, so you can win multiple times. So go ahead and download the app. A little bit about myself. I'm a proud father of 3. These are my little road rats. I've been a web developer since 1999, self-taught. I kind of was introduced into everything that year. Learned, back end and front end. Shortly after that, I went out on my own, and I opened up Fuse Developments, which is my company where I do all my consulting, and then CrossTracker, which is a SaaS that I built for the CrossFit community, where I got to play with a lot of WebSocket stuff. That's like where kind of like the fascination started. I'm also a senior developer at Duty Free Americas, and I am the South Florida ColdFusion user group manager. So before I start, how many of you are using WebSockets today? All right, great. Cool. How many of you know what WebSockets are? I've heard of them before. And then the rest of you don't know what WebSockets are or what they can do for you. Okay, so we'll start with that. So what WebSockets are? In the simplest form, it's basically a bidirectional TCP connection that's created between client and server, and it stays open the whole time, and it makes it really easy to send messages back and forth. So digging into that a little bit deeper, it's a full duplex communication channel for a single TCP connection. Again, it allows for the bidirectional communication of data between client and server. Because of this, there's little overhead. When you think about an HTTP request, the HTTP request header takes up a lot of information. I mean, we're talking bytes, but still, they're substantial. You're also sending cookies and everything, as where with this connection, it's completely open and you're not sending that, right? It's just real small messages going back and forth. So that creates very little latency. And allows you to program the web in a more event-driven fashion rather than user-initiated, or just not user-initiated. So what WebSockets are not, they're not push notifications. Push notifications is what you see on your phones nowadays, where your app can be closed and you get a little notification telling you something happened. That's normally done through the Apple's push notification services or Google's cloud messaging. That requires a lot of setup in order to be able to do that and push those messages, which is real handy, but it's not WebSockets. It's also not web push notifications, which is almost the same thing that you can do with a browser, right? Where the browser registers, and I'm pretty sure you've been on a site that says, hey, this site wants to tell you whenever there's a special or whatever, and you either say yes or no. And what that means is, even if you have the browser closed, you'll still get a notification from that service because a worker file was created, and then that connection was made, and then they know that when they send a message, they can send it to you. But all those are done through queues. So when you compare it to a WebSocket, this table really explains it real simple. So a WebSocket, you cannot deliver it to a closed application, right? The application has to be open. That's how the subscription has to be open, and then that channel is open between client and server. Whereas in push notifications, it doesn't have to be, right? Push notifications, the app could be closed or the website could be closed, and you'll still get that notification from the service. But there's latency to that. So with WebSockets, because the connection's alive, it's real time. It's very little latency. You might not even notice it, at most a couple of milliseconds. But with push notifications, it's usually near real time, but it all depends on that queue that you're being sent to that other service, right? You're just telling them, I need to push this out, and they're going to push it out in their own fashion. So again, that with WebSockets, because of the connection, there's it's a very high frequency, very little latency, whereas push notifications is low frequency because you are in a queue and these messages are going out to your clients. So to kind of take a step back and explain in a visual way the differences of what we used to do or what the HTTP architecture is. I'm pretty sure all of you kind of know this, but just going back to basics. HTTP architecture is really just a request that begins from a client, like a browser, and then the server sends back a response. This is called half-duplex communication. So it's just like a walkie-talkie, right? Both of you can't talk at the same time. One has to go out, and the other one returns. When we started building what we call, rich internet applications, and AJAX was introduced, or XHR requests, what a lot of us did to be able to update the UI or send messages or anything is do something called short polling. So I used to do this a lot too. So short polling is basically, once you can create that connection and you know that you can send an AJAX request, you would send an AJAX request like now. And you would say, tell the server, hey, do you have anything for me? And the server would be like, no, I don't got nothing. You say, okay, I'll do it in 5 more seconds. So that's cool on one person, on one connection. But you got a really busy site, you got millions of customers, and these millions of customers are making these requests every 5 seconds. And that server, every 5 seconds, has to make that decision for that one particular user. So you can see where that kind of becomes a nightmare. And again, there's a lot of network traffic. Every XHR request has a big HTTP header with cookies and everything, and it's not in real time, right? There's still that delay from when you're asking and when you're responding, and you could be, depending on how long you've made that decision to do that loop, behind 5 seconds, 10 seconds, 15 seconds, a minute, who knows. Then there was long polling. This one I was totally against, not something I ever really did, but I speak about it because people did do it. So what you do is you basically open the request and you leave it open. Now you do that loop on the server. The loop keeps that HTTP connection open, right? And it keeps asking itself, all right, is there an update? Is there an update? No, and maybe after 15 seconds you say, I gotta close this. So you send it back and say, no, there's no update. And then now on the client side again, you're gonna loop and do that again. Maybe another minute later, say, go ahead and open the connection again. When you multiply that in millions of users, you're killing your web server, because a web server is not meant to keep HTTP connections open, right? It's supposed to be just in and out, just get the message across. So this is where WebSockets come into play. So WebSockets start as a simple HTTP call that gets upgraded to a WebSocket persistent connection. That persistent connection creates that creates that connection where bidirectional messaging can happen in real time. So you can subscribe to channels, and you can publish the channels, and when somebody publishes or the server publishes, you're getting messages in real time and vice versa. So it's really just back and forth. And that stays open until one side closes it, whether you either close the connection programmatically, or you close your browser, or the server dies. So let's see this in action. It's pre-recorded, so here are some examples of how I've used this. The first one is a live form. I had built this form for Beauty for Americas, and they wanted to be able to build their menu systems, these custom menu systems for their drop-downs. Now, I did build the whole thing. I thought, well, this is really cool, but what happens if one person is like doing all this work, and the other person is working on the same menu, and now they override each other? So after I wrote this whole application, I was like, well, let me just take those little hooks and put in the WebSocket calls, and as you can see, when the person on the left does something, the one on the right tells it what the person did, and it updates the view. So that was a real interesting way of using that. The next one is a dashboard. You can envision that stores have this dashboard open, right? So they're just looking at it, and when customers are placing an order online, or through the app, or at a kiosk, or now at the POS that they have that we've built, the orders are shown here in real time. And as the orders go through each status, that dashboard moves. And it's not in this because I haven't updated this recording in a while, but we also went ahead and extended this and added it to the client side view. So if the user has their order open, if you've ever been on Domino's and you see when your pizza's coming and when it's delivered, that's basically it. We have that. And through each of these points, it keeps updating if the user has that view open. Next one is the progress bar. Our execs lack imagination. So sometimes when they want to test something, they want to test it with real data. So we have to pull everything from production into staging, but we have to do a couple of little tweaks and everything to the data so that real messages aren't going out and real transaction isn't being charged. So to do this is, quite a task, and to allow developers to have full access to production database sometimes can be a little sketchy. So we built this where basically they can execute this and it brings everything over as it needs to. Now this used to take almost 10 minutes. Then with a couple of updates, I actually got it down to a couple of minutes. But still, it's something that you would just see spinning wheels and you wouldn't know what's happening. It looks like it's broken, and what's going on here, and let me pause it so I can talk about it a little bit. What's going on here, when the call is sent to the server is running through everything, and through its progress, it's sending WebSocket messages back to the client. Those WebSocket messages contain text or instructions that update the UI, so it knows which progress bar to update, what text to input into the console. So somebody can be looking at this and it's 5 minutes later, but it's still working. It's not broken, there's actually something happening. So it just finishes, does its constraints, reloads ORM, all the beautiful stuff, and then the sync is complete. If any error would happen during the process, it would tell us at the end. So this is the whole enchilada. This is actually it being used in cross-tracker. So cross-tracker on the top right-hand side is what we call the whiteboard. So if you've ever been part of a CrossFit box, you know what that is. It's where everybody puts their name, and the WOD is up for the day. In the bottom right, that's a manager's view of their box. And on the left-hand side, that's what we call the coach board. So what I did is I had ran a script here that's basically acting as if people are either logging in through their mobile device, through a kiosk, through the website. And when that's happening, they're automatically being added to the class. Now, what I was showing here is how I'm going to do it through my website, through my account. And when I recorded this, I actually, by mistake, tried to add somebody to a class where the class had a limit. So good thing, because then I was able to go in here and show that I can come into the class, boot somebody out. That person's booted out, they're removed from the class, and I click here, and now I'm in the class. So all this is happening in real time, right? I know it's my box right here, but literally you can try this from different devices, and it's all happening in real time. So now here I'm coming in, and I'm putting in my results for the day. And in the bottom right, we have what's called the stats board for the day, and this is what we did to try to gamify, where you can come in and kind of see how you compare to your friends, because some people come in at 5 o'clock in the morning, some people come at 10, and instead of scrolling through everything and trying to find them, you have the stats board where they show up, and then you can compare people, and you can easily go to that board and start typing and search for, between groups of people or just by name. And on the right-hand side, the coach that's using the results, and as you can see in real time, they're being added to the screens, and the whiteboard, and the stats board, and the coach board. So that again is what you can do with WebSockets. So now WebSockets really didn't do all that, right? WebSockets was a medium to be able to create all that to happen, because then it took a lot of JavaScript to make that happen, right? So the way I use WebSockets is to send directions. Now the directions could be a small, JSON object that just tells me, whether if it's a value like a string, I can send a string, or maybe I send properties, and then in my JavaScript say, okay, if it's this, I'm going to do that. Or maybe I tell it, maybe I'm lazy, maybe I tell it, hey, there's something new, go refresh the page. I've done that too, right? When we don't have time, when we already have something that pulls the view, we don't want to keep asking for the view, we just say, hey, go pull the view, and then now it goes and pulls the view. So you kind of mess in both worlds. So WebSockets and ColdFusion. WebSockets and ColdFusion started support in ColdFusion 10. Now is everybody here, and I hope so, above ColdFusion 10? Anybody under? Anybody ColdFusion 9? No? Good. Nobody had to feel sorry for me. All right? So if you're in ColdFusion 10, you're still in bad luck, because that's when it was introduced, and there was no SSL support, and there was a 100 connection limit on standard. That's when I started to play with it. And back then, browsers weren't so strict. So you can actually be on a secure website and make a call to a non-secure WebSocket server. But that quickly changed, and absolutely no browser allows you to do that. So if you're working on a secure site, and ColdFusion 10 is what you have, you're basically limited and you won't be able to use it. It really just isn't usable. So as of ColdFusion 11, there is no connection limits on standard or enterprise, which is great. They introduced proxy support. This is my favorite way to set up my ColdFusion, my WebSocket servers, because it's just very easy, especially if you're dealing with SSL certificates. They introduced SSL support, that if you're working with proxy, you really don't need to worry too much, but if you're working with the internal WebSocket server, you're going to need to do some things to be able to make that work. And they introduced cluster support. So that is the only enterprise-only feature, right? You have to have enterprise. And what that allows you to do is, you can imagine, just create a cluster of WebSocket servers that can talk to each other. So how do I use this, right? How do I use WebSockets in ColdFusion? It's real easy. First, we enable it in the ColdFusion administrator. It has its own administrative page where you can choose your ports, whether you want to use proxy or not, and put all the settings that it needs. We define channels in our application CSV, which I'll show you in a bit. You use the CF WebSocket tag, so it brings in all the JavaScript that the Adobe team did for you to make it as easy as possible. And then you write some JavaScript and get creative. So how does that look? On top is what you would do in your application CSV. So you have properties called WS channels, and that is an array of structs. And then the struct takes a name. That's the name of your channel. So there you can see that I have demo and chat. So basically, these are like two different silos where people can subscribe to. And then you can do child channels, and those are dynamic, and they're dot syntax. So demo.room1, demo.room2. Once you subscribe, and if you're the first one, you'll automatically create that room. You don't need to define those here. Here, you only define the parent channel. Then we have CSC listeners. These are like server-side callbacks, which we will go into detail in my second presentation. The second presentation is more like a live coding and hoping everything goes great. So that'll be interesting. But I'll go in depth into what they do, how they work. Then the CF WebSocket tag. You can write it in script or in tag. I did a tag here, so it's easy to understand. The CF WebSocket tag has a couple of attributes. Name, this is what it becomes as the global JavaScript object that's going to contain everything. So WS, right? So that's basically like window.ws. And this is going to be an object that has functions that you can take to connect, subscribe, unsubscribe, everything that they offer. On message, this is what you're telling it that once you receive a message, this is the JavaScript function you want to run. So you would need to define this function in a JavaScript file at the global level. So window on message. On open, this is what you want it to do when the connection is open. On close, on error, you can pretty much see that. You're just giving the name of the global JavaScript function to process that response. And then you have subscribe to. Subscribe to, you can put a comma delivered a string of all the channels you want to subscribe to. So this is really the easiest way to start with with WebSockets, especially if you're not doing any type of authentication or anything special, if you're not passing any special attributes. This is the way you would do it. If you want to do a little bit more advanced, you would basically just put everything and you don't use subscribe to. You would then use the JavaScript function that's available to you, which I'll show you on the next slide. It also has other attributes I didn't put here. It's called CFC auth. And what that is, I believe, because I don't use it, is if you use CF logging, right, and you require authentication, if you put that CFC auth equals true, then it would use that authentication, and you won't have to go through the manual authentication process of being able to subscribe to a channel. And then there's also secure. So secure, if you're using the internal WebSocket server, you would need to put that true if you're running off a secure site. If you're on the proxy version, don't even worry about that attribute. It'll actually cause problems if you have it in there. And in the bottom, that's what, again, this is very simple. Just function on message. I'm going to receive a message, and here I'm just logging out that message. But in there is the whole package of what you would work with. That's what you would need to look at. So the client functions. Client functions again, and here I kind of, can everybody see that well? I hope so. So we have, these are the messaging functions you get. So subscribe, publish, invoke and unsubscribe. And if, based on WS, right, what I call that object, the way you would work with this is you would do ws.subscribe in JavaScript. You pass in the channel, which is a string. Then you can pass a custom header, and you can pass in a message header. So the only requirement that you would need is ws.subscribe and the channel number. A custom header is something that you can pass, again, an object with key value pairs, right, of whatever you want. So for instance, here in my app, I need that when this person is going to subscribe, they're on a mobile device. So I want to say device mobile, right? And then the message handler, if you want to override the on message that you would define on CF WebSocket, let's say we have on CF WebSocket on message, I want you to run on message. But when I subscribe to demo, I want you to run a function that's called demo on message. You would just put that name in there because that would be the callback to the function. So it's not a string, you just put the name of the function that basically refers to that global function. Now when you publish is really easy, right? Once you're subscribed to a channel, you put the channel, you pass the message. Message can be anything. It can be a string, it can be an object, it can be an array, whatever you want it to be, you can pass it. And then a custom header, that is optional. So the custom header, just like when you subscribe, you can pass more information that maybe you might want to do something on the server side. But the cool thing that they have is this selector. So selector, as you can see, that one says device equals mobile. So this means that there's 10 people subscribed to that channel, and 8 people have device set to desktop, 2 people have device set to mobile. Only the people who have device set to mobile will receive those messages. So 2 out of the 8, or 2 out of the 10, right? And this is right out of the box. You don't need to do anything. There's nothing to do with CFC, with the CFC listener, nothing. They basically have this baked in right in for you. So that makes it really interesting and really cool. Invoke and publish. This is a way to invoke a CFC, and you're able to, when you use this function and you put in a channel, right, whatever that CFC returns at the end is what's going to be broadcasted to everybody on that channel. So you basically put the channel, you put the CFC name, which is in dot notation, so wherever it is in the path of your website, of your app, and then the function name that you want to run. Then you can pass an array of arguments if it receives arguments, and you can pass in that custom header all the way at the end. Those are all optional. The arguments and custom header are optional if you don't need any arguments. Invoke is where you create a point-to-point connection. And I used to always be really confused about this because I always thought point-to-point was like another client. Point-to-point basically means you and the server. So the functionality is only between you and the server. This is called channelless. That means there's no channel involved here. You're basically going to invoke the CFC and it's going to run something. And then it'll be able to talk right back to you by using a server-side function called WSSendMessage. It's only used when you invoke. One scenario here is basically if you're using WebSockets, why call an AJAX call to do something for you if you can call it this way? It's much lighter, it's much faster, you already have the connection open. And if that needs to process something, and let's say that process takes a while, rather than keeping that HTTP connection while that runs, you just send out the call, and as that, whatever that CFC is doing, it can then broadcast a message back to you, and only you, nobody else will receive it. Unsubscribe, real easy. You unsubscribe, you pass the channel, and then you're out. These are some other ones. Authenticate. This is when you're using the authenticate method. With WebSockets, you basically just pass a username and password, and on the next slide, I'll show you how to use that. But you basically, with the username and password, you do whatever you need to do, whatever you need to validate that person, whether it's you're checking a database or a flat file or whatever it is that you have for authentication. This is where you would pass it. Get subscriptions gives you an array of the subscriptions that you have. So this is how you can tell you what you're subscribed to in case you forgot or if you're doing it dynamically. Get subscribers count, you pass in the channel name, and it gives you all the subscribers for that channel. Open connection is, again, that's pretty much what it is. You open the connection, close connection, you can close the connection. And then there's disconnected and disconnection open. I wouldn't rely on these too much. These sometimes have given us headaches where like you think they work and then the server goes down and your ask is connected and you turn it true. And on some fixes it works, and on some fixes it doesn't work. So right now, the latest ColdFusion fix, hotfix, it works. Shut down the server and it tells you false or broken. But again, you never know. So server functions. On the server side, we have WS publish. So this is the server initiating a message back to the clients, right? Because really WebSockets, if you think, like, let's think of the chat example, right? It's really just the subscribers making those messages and sending them back and forth. But from the server, if the server wants to do this, the server just executes WS publish, puts the channel name in there, puts the message, whatever you need it to be, whether it's a struct, an array, a string, and then any filter criteria that you want to pass in. WS get all channels basically gives you all the channels that you define in your CFC. This is an easy way if you're building yourself a dashboard of like who's subscribed and all that. You can loop through that, and then when you loop through that, you can pass the channel name to WS get all clients, which then you loop through that, and you get an array of struct with client IDs, and then you subscriber info and keys. And then WS send message. This is the one that I told you that when you do that invoke, this is the one that you send, and it knows, the server knows that that message only goes back to that user. So it's using the point-to-point communication to send additional messages to the client. So the server response. When you get back from the server response, there's more keys than these, but these are the ones that you probably work with the most. So that's why I kind of broke them down here. So the client ID, that's the unique ID that's given to you. When you subscribe, this is your ID. The publisher ID is if the message comes across and somebody else sent it, it's their ID that comes, so you can kind of like see, just have an idea of who it is. If that value is 0, you know it came from the server, so WS publish. The channel name that this response came through, in case you're subscribed to multiple channels. The type, whether it's a response or data. If it's a response, you'll normally see something in the message key, which applies to responses. You get an OK, successful, and if it's an error, it's going to give you the cause and failure. And if it's data, you're going to look at that data key, and that's going to contain an object, whether it's a string or an array or a struct, whatever is sent. That's where you're going to look for your data set. Channels. So to go into channels, and again, channels are defined in the application CFC. You can have an endless amount of child channels created dynamically. When a user subscribes to a parent channel, they also subscribe to all child channels. And a user who subscribes to child channels does not subscribe to its parent channel. So, luckily I didn't know I'm saying that, but a visual representation of that is in this table. So I have 4 clients. The client on the top is subscribed to stocks. And they receive messages for stocks, stocks.finance, stocks.banks, stocks.finance.adobe. Right? You can create these on the fly. The second client is only stocks.finance, so they're going to only receive messages for the second, the second column, which is stocks finance, and they're going to receive messages for the child one. So it's not like, basically, the way you see it is if you're from the top, you view everything, and then everything kind of silos down. On stocks banks, only gets it from the third one, which is the stock banks channel, and the last client is subscribe to stocks.finance.adobe, so they'll only get messages inside stocks.finance.adobe channel. So the messaging framework. On the application CFC, there is a function that you add is called on-WS authenticate. This is where when you do WS authenticate, that's the function that's going to handle all the work for you. So it lives in your application CFC. It accepts a username, password, and connection info. Again, if you pass in connection info, you can add to the user's record. And here you can handle authentication however you want. Again, whether you're doing it to a database or some file or maybe some network service. This is where you do all your logic. Then you have your CFC listener. Your CFC listener gives you basically callbacks of what to do. So when you call subscribe, the CFC listener will check in, allow subscribe, and see for any business logic in here that will allow you to return a Boolean saying this user can subscribe or cannot subscribe. The same thing with allow publish. When you send allow publish, what you're going to receive is that publisher info. You can do some business logic there and return either true or false to let you know whether this person can publish. So if I try to publish a message to a channel I have no access, and that says no, my message is not going to go across. Then there's before publish. Before publish receives a message and the publisher info. Now this one, these next ones is kind of understand really how they work. So before publish only fires off once for the message. So I send the message, and before the message is broadcasted to everybody, it's going to look at it, and let's say maybe if you have something that looks into like a bad word database or whatever, and make sure that you replace anything in the message, or you clean up the message, or nothing important, anything that's proprietary, whatever business logic you want to do to the message, you do it there for the whole group. So that only fires once for that message. After that, can send message fires off. So that sends the message, the subscriber info, the publisher info. So here again fires this. Now this starts firing for each client. So when the message comes through, it's going to look at me as a subscriber. It's going to say, okay, can this person send this message? And if so, then it goes ahead and fires off. And then before send message, actually I think I got that one. The before send message is invoked before sending the message to the subscriber client. So this one fires off for every single one. So we're before publish only fires once for the message. Let's say there's 100 users subscribed. This process is going to fire off 100 times. Because this is where you want to grab the message and maybe personalize it for the person. Like, hey, JC, blah, 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 you know? So then you'll look through each single one and you'll format the message and then you'll finally send it off. And after unsubscribe is something that fires off when anybody unsubscribes, whether that's by programmatically doing it with WSN unsubscribe or by closing the browser, that automatically fires off. And then this is a visual representation, which I didn't get to update that, but basically how it kind of works. So you have the client, you have the WebSocket server, you have the CFC listener callback layer. When you authenticate, you're going to get that you're going to send the message and you're going to get either true or false back. Same thing when you subscribe, and then when you publish, it goes through all that process and then sends the message back down to every subscribed client. So server requirements. If you're using the built-in WebSocket server, which is what you're required if your server doesn't meet the minimum criteria, or if you're working with clusters, you'll need to open up ports on your firewalls for the secure and non-secure connections. Now, the ports up here are the defaults that you'll see in the administrator, but if you're working with different instances, you'll have different ports and so on, or you can change them. If you're supporting older browsers, which I really don't think any of us are, is anybody supporting IE9 anymore? No? All right, so you don't have to worry about this. They have a flashback, and if for any reason you had to, that port is defined in Neo WebSocket XML. It's 1243. And you would have to add your certificates to a Java key store or a PCKS12 file. And you grab that file, you upload it, you point to it in the administrator, and then you put the username and password. So this is what you have to do if you're using the internal WebSocket server. So that right there takes a couple of steps to do, depending on whether you're on Windows or you're on Linux. There's different steps to do it. It can be cumbersome, but if you're comfortable with it, you can. It's not hard to do. It's just, again, it takes a couple steps. If you're using proxy, which is the recommended way, it's the easiest way. The only thing you need to be is if you're on Apache, you need to be on 2.2 compiled with a worker module, not pre-fork. And if you're on IS 8 or higher, you need to enable the WebSocket protocol. So basically what that looks like there, and I don't know if you can see it very well, but on the top, I've never really done it with Apache. This is the Apache that comes with my Mac. But when I check what it is, you can see that the server npm is pre-fork. That needs to be worker. So if you want it to work on Apache, you need to make sure that you build Apache with the worker module. And that has its pros and cons that you can read into a little bit later. And with IIS 8, when you're adding ISS to the server, or if it's already there, you go to your server manager and you go add roles and features, and you just kind of step through it. You'll see that down in the application development features, the last one says WebSocket protocol. Because now IIS and .NET have that enabled. So you enable that, and that's all you need to for your server to be able to use the proxy. So these settings and file locations. Settings and files, they're, again, the CF admin, server settings, WebSocket. This is where you'll find all the settings for the WebSocket. If you are, for some reason, having to support old browsers, you have to make sure that the Flash is enabled in the Flex integration admin. Then you would need to go to your instance, make sure that port that's defined in your WebSocket XML is open. And if you're using the proxy, then what you would need to do is you need to fire off WS proxy config as an administrator, right? So if you guys know WS config is how you do the connector for the website, you need to do the connector for the WebSocket, and that is under bin, right from the ColdFusion instance, unlike WS config, which is under runtime bin. Would have been easier if they're all in the same place, but it's fine. That's where it is. That will create a virtual application, on your site called CFWS. And the configuration for that would be under config, WS proxy, the site number, bin, config, INI. This is where like the port number is defined and everything. This is everything that WS proxy config does for you. And it's important to know these locations. So again, just working on IIS, this is what you would see. You fire off that WS proxy config, and then you do that mapping, and it creates that little folder with your CFWS, which, I'm sorry if it's blurry. So, things to watch for. If you're, again, this is all IIS related. If you're on IIS, make sure that your application pool must be set to .NET framework 4 or higher. If you're working through the ColdFusion If you're working through the ColdFusion lockdown guide, we normally know to set them to unmanaged code if they're not using .NET. But if you enable this, make sure to go back and set it to .NET framework, or else it won't work. When you run WS proxy config, go ahead into that virtual application, right click on it, go to properties, make sure that the application pool is assigned to the same one as the parent of that site. There's times that it's been fixed, and there's times that it's been broken, and it will always set it, and it will set it to default, even if you don't have a default application pool assigned. That's the name that's going to put in there. So if you're trying and it's not connecting, and then if you try to go to the URL alone, you get some ugly .NET error, that's pretty much the problem right there. I would say about 90% of the time, that's what it is. The other 10% of the time is if you're working with instances and you're not paying attention, and then the port that is defined in the admin and the port of the WS proxy config is showing you are completely different, and you run it and you don't know, and for some instance you're like, man, the application pool is the same, but it's not working. Look at those ports again. Go into your CF admin, look at the port, open that INI file or the WS proxy config, and if you see the change, if you see a difference in number, that's all it is. Go ahead and save that INI file with the new number, or update your WS admin, your WebSocket admin, whichever one would be easier for you, and then just do IIS reset, and you'll be okay. It'll be working. If you add a new top-level channel to your application CFC, you will need to restart ColdFusion. Not an application rename, nothing like that will work. You will actually have to restart ColdFusion. So if you add a new channel, you basically have to bring the server down and bring it back up. If you're using proxy method, make sure that none of your CF WebSocket tags have the secure attribute set to true. If you're using proxy, again, that will cause it to just bomb. Something that I've run also is to always wrap my WS publishes inside of their own thread. Especially if you're working like with frameworks like Framework 1 or something like that. I've noticed that when I didn't do that, it would break the request. So the response I was waiting for would just never come, or it would just act weird. So what you do is always wrap this into their own threads. There's no callback you need from it. You just need to send that off on its own. Let it do its work. Doesn't matter. Just let it go. And if you delete a site on IIS without removing it with without removing the proxy, either do an IIS reset or run WS proxy config again, and it'll fix any issues that your IIS server might be complaining about. So again, we're coming close to an end already. When you're looking at WebSockets, if you're for clusters, and just quickly going through this, the way you can imagine it now is the way you'll set it up. Normally you have your instance and you have client A and client B. With the WebSocket cluster, what that allows you to do in your enterprise setup is create another instance, which client C and client D can then subscribe to, but then you create this port that they all talk between. So what ends up happening with client A sends a message, that message goes to client B, but then it's also sent over this other port to the second instance, and the same message goes down to client C and client D. And if one instance goes down, then the subscribers will automatically subscribe to the other instance. So that's the benefit of working with WebSocket clusters. It is a little bit of work to set it up and even test it, because you're bringing servers down and kind of waiting and how long it takes. And just looking at it, I did it one time in a presentation, but I won't do it again. So the way you do that in your CF admin, you must use a built-in WebSocket server. You create the instances in your instance manager. You define your clusters. You rebuild all your connections, and then you turn on WebSocket clustering on all instances, and that'll be right in the admin. You'll actually see all that in the admin. And then you just have fun testing.
Spread the multiple channels at one time. Can you publish to multiple channels, or
Well,
you have to do that individually?
You could subscribe to multiple channels at one time, but you're basically calling that WS subscribe each time for each channel. It's not like you can pass it all, but you can't pass all those channels in that call.
When you subscribe?
When you
Is there
subscribe,
like a comment limited?
that's in the attribute, in the attribute of the CF WebSocket tag, because that's going to run the connection for each one.
Okay.
So, but if you're doing it yourself, you need to call WS subscribe. Well, subscribe yourself, and if you're publishing, you would have to publish to the individual channel yourself. So you have to specify which channel you want. Is there
a way to get the slides?
Yes, all these slides are available on my GitHub, but since I just worked on these, I'm gonna publish them, and then I'll send a tweet of where they're at. But all my code and everything, if you're coming to the next session, everything's gonna be available on my GitHub. And I did do some updates, so just wait until I push everything up. Any other questions? Yes.
So obviously this could be very helpful for millisecond or small second requests. Is there a threshold you feel where once you can allow it for a minute or 2 minutes where you say, you know what, we don't need the WebSocket, just do polling, where it'd be more beneficial versus keeping a socket open?
Well,
there a threshold at all?
So your question is whether, if, like, to kill the socket connection, right? After a while, like if I don't need it, just unsubscribe.
If, let's say I have multiple processes and I know that these processes I want to be, real-time communication, but I have these other processes where it would be nice to know maybe after, a minute, if I'm expecting for it to run for an hour, I want to know updates. Is there a threshold where you say, you know what, it's not real-time, you can just do, polling instead of keeping this WebSocket connection open? Is there a threshold, or can you just say, have tens of thousands of WebSockets and it's no?
You can have, the purpose of it is to have all those connections open, but if you know in your application that you don't need that connection open, like if you received everything you wanted from it, then you would programmatically just unsubscribe and then you can kill the connection by just closing the connection. And that would just leave that connection open for somebody else. So if you don't do anything, yes, it'll stay open. And there's nothing that you can do, like say, okay, if nothing happens after a minute, automatically close it for me, you would actually code that yourself in your application. Does that kind of answer the question, or?
It kind of answered part of it, but as far as when you're building out an approach for a specific process, if you were looking at the problem and we're looking at a solution, you were wondering, well, is WebSocket's good solution for this particular problem? Is there a threshold where you say that I don't need information that fast, that real time, so I'm not going to bother doing the WebSocket, I'll just make new connection requests?
I think that comes down to architecture, right? You make that decision. If the reason you need it is to have that real-time data, you can use the WebSocket. Like if you want that low latency, like if you're doing a game, right, and you're taking action and you need the person on the other end or people to receive that as fast as possible, then you would use the WebSocket connection, right? If you are using something like chat, right, and you don't want the messages to appear so delayed, you can use WebSockets. Even when doing that form, right, you want to see real changes live, something like that. But another scenario where maybe you don't need to know that price of the stock like every second, right? You're okay finding about it in a minute or two, then yeah, just use a regular AJAX request, because if it's so far out, then why waste that socket connection? Yes, that's the way I would see it. Yes.
I know there's other services you can do your WebSocket server through, but realistically, what kind of load does without going into clustering, what kind of load can you expect that the built-in WebSocket server that comes with ColdFusion can handle?
As far as I understand, it can handle millions, right? And I think with like Socket.io or any other service, it kind of tends to do that. I've never had an issue where a Socket server has died.
Okay, that's what I want.
And again, like kind of a disclaimer, I've never really tested it either. Like, okay, let me make it fail, because like creating the WebSocket connection actually you require a client and all this, but when I've seen hundreds of connections, especially with Duty Free Americas, where you have all these stores, you have all these users on their mobile devices, you have these kiosks, everything is connected. It's running smooth without any hiccups. Any other questions? Yes. Oh yes, sorry. No problem. Yes.
When you were talking about the built-in WebSocket, what's the alternative to that?
I'm sorry?
You were talking about the built-in WebSocket.
Okay, because here, I'll show you. Well, all right, if anybody wants to, I can go to my browser real quick and I'll bring it up. Give me 1 second. So if anybody asks if you're using command box, whether it will work, yes, it will. As you can see, I'm starting the server right now. But it will only work with Adobe ColdFusion. I think Lucy requires a couple different things, and Lucy's implementation is different than ColdFusion's. All right, so now I'm here. when you're looking at your settings for your WebSocket, you enable the WebSocket server, and if you're using the built-in WebSocket server, right, so that's the internal one, it means you have to talk to it through these ports, right? So there's your regular non-secure port, and here's your secure port. If you enable that secure port, you need to either upload a key store or a PCKS12 file, whichever one you're more comfortable working with, then the key store password, so in order for ColdFusion to be able to read that store and say, okay, this certificate is good for this site.
Is that even if you're using proxy or?
If you're using proxy, you don't have to worry about any of that. If you're using proxy, and again, because when you're using proxy, just enable this and nothing else matters. Like none of the other settings matters because with proxy, it will take what's defined in your web server. So that's why it's so easy. You don't have to worry about any of this stuff. The only thing is, again, if you need to use a WebSocket cluster, this is where you enable it down here. And that's the multicast port. That's that port that does the magic between instances and make sure everybody receives messages no matter what instance they're in. Any other questions? Yes?
Have you built any applications like this that are using server to server or multiple servers communicating?
No, I've never, I don't even think you can do that. In server to server, I do like just API requests. I don't really know like REST APIs. And that's the way I kind of work from server to server. Because again, like with the WebSocket, it requires a client connection. So a lot of, a lot of different languages have the ability to do that. Like with .NET, .NET, they have their libraries built into everything. So I had seen this one real cool demonstration where the guy did, of course, a WebSocket connection to a website, which is normal, right? But then they did, now I get this wrong, forgot what it was. I think it was Windows Forms, whatever, that did like an application on the actual OS, and that created the connection. And because it's a client, they were able to do. This guy had done something that was just a drawing canvas. So the drawing canvas on the browser was drawing, and then the one on the application that was native was drawing, and all that. And that's all happening in real time because as the user moved their hand, and all those directions were being sent to every client that was listening. But you need a physical client, right? And I know a server is a physical client, but I don't know, I guess I have not seen like a library to do that from server to server. So that's, I have no answer for that. Sorry.
Oh, thank you.
Any other questions? All right, well, thank you again for coming. Remember to download the app, fill out the surveys, thank you, which will allow you to sign up for an Amazon gift card and do it every hour. Hopefully we get more than one. Thank you again.